Sorry about that. YouTube only lets me do 10-minute videos and then it automatically shuts it off. So we ran out just as we were solving for delta t here. So fill in your delta d is 12 meters, your acceleration that you just found, do the math, take the square root, and you should get a time of 12.419 seconds. Okay, so that's number 25. So now let's move to number 26. Number 26 is a skier coasting down a ramp. Now coasting means he's not pushing, okay? So there's no pushing going on. He's just letting gravity pull him down. And there is friction acting back. And it says that he's coasting at a constant speed, so AX is 0. Now if you need to, you can find your FGX and FGY. FGX, hopefully you recognize, that's theta there, so it's going to be cosine. So cos theta will equal FGY over FG. So FGY will equal FG cos theta. And so that means FGX should be FG sine theta. So we do sum of the forces in the y. He's not moving in the y. So it's just Fn minus FGY equals 0. So Fn is going to equal FGY. So that's going to equal FG cos theta, which we know is really mg cos theta. Even if you wanted to this time, you can't get a value for this because you don't know m and you don't know theta. So we go to the x direction. In the x direction, we have FGX acting down the incline and friction acting up the incline. So we have and he's moving down, so the FGX is positive. Minus friction, oops, this is not friction, minus friction, and he's coasting at a constant speed, so that's 0. So FGX, since FGY was FG cos theta, FGX is the opposite side, so it's sine theta. And that's going to be equal to friction, which is mu Fn. And of course we just found what Fn was, so this is mg sine theta equals mu mg cos theta. So now you want to solve for mu, so divide both sides by mg cos theta. So you'll have mu equals mg sine theta over mg cos theta. I think my pen's dying. And so then the mg's cancel. What did I just do? There we go. The mg's cancel. Sorry, trying to open my pen. And you're left with sine theta over cos theta. So the mg's cancel. There we go, that's better. So you have sine theta over cos theta. And you could just fill your angle in. But some of you might know that there's a trig identity with sine theta and cos theta. Sine theta, you know, is opposite over hypotenuse. And cos theta is adjacent over hypotenuse. So if you divide sine by cos, it's like dividing opposite over hypotenuse by adjacent over hypotenuse. Dividing by a fraction is the same as flipping this fraction and multiplying. So it becomes opposite over hypotenuse times hypotenuse over adjacent. The hypotenuses cancel, and you're left with opposite over adjacent, which perhaps you recognize as tan theta. So really this is sine over cos is just equal to tan theta, so this is really mu tan of 3.5. And so do the tan of 3.5 and you get 0.06116, I think. Okay, for your mu. All right, turn the page, move to number 27. And in number 27, you're flicking a coin up an incline. So as you flick this coin up the incline, you're giving it an initial velocity of 2.3 meters per second. And it wants to know how far up does it go before it comes to rest, before Vf is 0. So to do that, you're going to need to find the A. So again, hopefully you can look at this triangle by now and say, oh, FGY is just FG cos theta, and FGX is just FG sine theta, opposite and adjacent. So then go and do sum of the forces in the y direction. is equal to MAY, not moving in the y. So we have Fn going up, FGY going down, equal to 0. So Fn equals FGY equals FG cos theta, which of course is really mg cos theta. Now we're going to do some of the forces in the x direction. So in the x direction, you're flicking the coin up the incline, so friction's acting down. But once you flick it, you don't continue to follow it and push it. So there's no forward force up the incline. Okay, there's just friction acting down, and don't forget your FGX. So we have opposite motion, FGX, so it's negative, and friction, it's negative, is equal to MAX. FGX is really just mg sine theta, and friction is really mu Fn equal to MAX. So minus mg sine theta minus mg cos theta is equal to MAX. So over here, when you found Fn, you could have gotten a number. You could have taken that 5.5 grams, changed it to kilograms, multiplied it by 9.81, and divided it by the cos of 25. Don't do it. It will be a horrible number. Also, don't do it because now to solve for A, you're going to divide everything by m, and they're going to cancel. And so you don't need to deal with that 5.5 grams. A is just going to be negative g sine theta minus, I think I lost a mu right there, minus mu g cos theta. Okay? And now you're going to fill your numbers in. So AX is going to be negative 9.81 meters per second squared times, I think it was the sine of, it was 25, right? Check. Yeah, sorry, I knew it was the sine, it was the angle when I said I think it was. Sine of 25 minus the coefficient was 0.4 times 9.81 meters per second squared times the cos of 25. And when you punch all this in, you get negative 7.70, sorry, wasn't looking when I was writing, 22 meters per second squared. And so now we go back over here and we use that to find our delta D. So we have VI, we have VF, we have A, we want delta D. So VF squared is equal to VI squared plus 2A delta D. So rearranging for delta D, VF squared minus VI squared over 2A. VF is just 0. So negative 2.3 meters per second, and you're squaring it, over 2 times negative 7.7022 meters per second squared. And of course I didn't mark it over here, but this negative just means it's slowing down. Okay, so punch your numbers in and get your delta D. And I believe when you do that, you get 0.3434 meters. Okay, the end to number 27. Number 28, you're actually pushing it up the incline. So you have a force of 373 newtons, and it says you're pushing at constant speed, so AX is 0, and it wants mu. So of course you're going to start with some of the forces in the y direction. Not moving in the y. There's an Fn going up, an FGY going down. So Fn ends up equaling FGY, which hopefully when you look at the triangle, you'll say, oh, that's the adjacent side. So it ends up being FG cos theta or MG cos theta. Go to the x direction. Sum of the forces in the x direction equals MAX, which goes to 0. So you have the force you're pushing with, minus the FGX acting down, minus friction acting down, equal to 0. So F minus FG sine theta minus mu Fn equals 0. Trying to solve for mu, so take this term over. So it'll be F minus mg sine theta equals mu, and Fn is mg cos theta. Solving for